So this video is about what is chordal distance in non-commutative phase, and Alain Connes says that music is the best way to explain this, and by music we mean actually just the two notes that make up a chord on the beginnings of a chord. And so the paradox here is that when you listen to the source of the sound based on the natural harmonics, you start with the number one as that is the source of the sound. But as Connes reveals, music from time and frequency is actually non-commutative. And so you find this paradox a lot when mathematicians or other scientists try to analyze music, and then musicians even make the same error because they're just relying on what they think is the smarter science stuff from the mathematicians and the physicists. But so you have to really study high-level mathematics to then figure out that the truth of the Pythagorean music is actually non-commutative phase. And so when they say, well, Pythagoras didn't really create the Pythagorean theorem, and he was, they discovered it, but he was against it. And this whole paradox of the Pythagorean theorem is the foundation of science, so it's even used for relativity. Well, the problem is that even when you use Riemann geometry for relativity, using spheres and curved spacetime, even Riemann realized, as Connes points out, that at the level of light and the speed of light, that light can't be just a particle or a point on the continuum, that it has to be a non-commutative time and frequency. And so people like to point out that if you square 0, then it's equal to 1, as if this is some great mystery that proves, exponentials and logarithms. And but the problem is that when you're using infinitesimals in calculus, as math professor Louis Kaufman points out, the infinitesimals in a perpendicular space of x and y do not commute. So even though each infinitesimal, if you square it by itself, then it equals 0, even though it's an infinitesimal, so it's a process that's not 0, but when you square them when you multiply them against each other, then they're non-commutative, so that the value reverses. And this is also what you find in the truth of music theory, so that the value of the one when you're listening it's based on the doubling as an octave, so it stays the same pitch in geometry. So this would be the equivalence of symmetry in geometry. But the problem is that when you double from the opposite direction, then it's a non-commutative change. So that when you assign a geometry to the numbers, so the number 3 in one direction is F, and then it's in the other direction it's G. And so what the mathematicians will do is they'll try to equate E. They'll switch to music theory, so they'll say E to B is ratio of 4/3 going down, and then they'll say A to E is the ratio 4/3 going down. But if you're changing what the value of the 1 is, then you're changing the doubling of the symmetry. And so this is what I call the wire and the wire, because it requires flipping the space around of the wire, and by flipping the space around, you're changing the direction of time as well. And so in relativity, they're assuming that the spatial measurement enables also time dilation when you're close to the speed of light. And so they're deriving the time as the distance divided by the speed. And then they're using the light as the clock, the time. And so then they realize that there's actual time dilation when you have to subtract for the Pythagorean theorem. But this is based on the assumption you have two different measurements in space, and so the time is a spatial measurement. But in fact, in non-commutative time frequency, the chordal distance is actually from the fifth dimension of time in a zero-dimensional space. So therefore, it's based on pure time and frequency, and the different frequencies are then considered to be discrete points, but it's based on arithmetic distance and not geometric length. And this was the big point of the logical proof of Charles Sayward and Philip Hugley. They're both philosophy professors, and in 1999 in the journal Philosophy, they published an article, Did the Greeks prove the Pythagorean theorem? And they said no, because no matter what you want to claim, geometric length is not the same as arithmetic distance. And so normally we would just think that that's just a logical semantic argument, because obviously everybody uses the Pythagorean theorem for whether it's like building construction or deriving time or moving, as I just pointed out, time frequency. And you can find this same truth in traditional Taoist music theory as it relates to Taoist meditation, or the three gunas of India as it relates to yoga meditation. So the truth is hiding right out in the open, but unless you study non-commutative phase geometry, then you don't realize that the Pythagorean philosophy is actually this non-commutative quantum